Good day. I am Alexis Jean L. Sadiwa, a representative from Group 5. The situations we chose are the problems 1 and 5. And I am going to explain how we get the answers from the problem number 1. So this is the formula. Final velocity y squared equals initial velocity y squared plus 2 times acceleration due to gravity times delta y. We have to square both sides so that we can get the final velocity. So we will square final velocity y squared equals the square root of initial velocity y squared plus 2 times acceleration due to gravity times delta y. So we will substitute the value and we will get the square root of final velocity y squared equals the square root of 20 meters per second squared plus 2 times negative 9.8 meters per second squared minus negative 30 meters. So the value of 20 times 20 is 400 meters squared per second squared. And the value of 2 times negative 9.8 times negative 30 meters is 588 meters per meter squared per second squared. And we will get the value of 988 meters squared per second squared. Then we will square the both sides and we will get final velocity equals plus minus 31.43 meters per second. Since we will get the velocity before it hits the ground, the answer will be negative 31.43 meters per second is his velocity when he hits the ground. So this is for the question number 1, letter A. And so for the B, the given is 20 meters per second for the initial velocity and the acceleration of per gravity due to gravity is negative 9.8 meters per second squared and the delta y is negative 30 meters. And we got the final velocity in the first problem. So we get negative 31.43 meters per squared. So the unknown for now is the time. So the formula is t equals final velocity minus initial velocity over acceleration due to gravity. And here is the solution. So the formula is t equals by minus boy over a, and the time is equals to, and we will substitute the value and it will becomes the time equals negative 31.43 meters per second minus 20 meters per second divided by negative 9.8 meters per second squared. So we will come up and the answer for the time is 5.24 seconds, and the answer is 5.24 seconds is the time it takes to hit the ground. So thank you very much, and Dexter will explain the solution for the problem number 5.
The second problem we chose is number 5. The Zero Gravity Research Facility at the NASA Lewis Research Center includes a 145-meter drop tower. This is an evacuated vertical tower through which, among other possibilities, a 1-meter diameter sphere containing an experimental package can be dropped. So our given in problem number 5 are delta y is equal to 145 meter, a 1-meter diameter sphere, a is equal to g, that is equal to 9.8 meters per second squared, and an initial velocity that is equal to 0. So in our letter A, we have an unknown time, the experimental package in free fall. So our formula for letter A is negative delta y is equal to initial velocity times time minus 1/2 times 9.8 meters per second squared times time squared. 145 meters is equal to 0 times time minus 1/2 times 9.8 meters per second squared times time squared. We are going to derive the formula into time squared is equal to 2 times 145 meters divided by 9.8 meters per second squared. Square root of t squared, or time squared, is equal to square root of 29.59 seconds squared. And we have an answer. Time is equal to 5.44 seconds. The time for free fall is 5.44 seconds. So in our letter B, the unknown is the speed at the bottom of the tower. So our formula for letter B is final velocity squared is equal to initial velocity squared minus 2a times negative delta y. Final velocity squared is equal to 0 plus 2 times 9.8 meters per second squared times 145 meters. Square root of final velocity squared is equal to square root of 2,842 meters squared per second squared. Final velocity is equal to 53.31 meters per second. So the speed is 53.31 meters per second. In our letter C, the unknown is the distance does it travel in coming to rest. So we have in C we have a given A is equal to negative 25g. Final velocity is equal to 0. Initial velocity is equal to 53.31 meters per second. We got 53.31 meters per second from our letter B. In C, we have a given that is 25g na acceleration. And because it is free fall, it will become negative 25. So our formula is final velocity squared is equal to initial velocity squared plus 2a times delta y. Delta y is equal to 0 minus 53.31 meters per second squared divided by 2 times negative 25g times 9.8 meters per second. Negative 2,841.9,561 meters squared per second squared divided by negative 490 meters per second squared is 5.7,999 meters. So the sphere with an average acceleration of 25g travels 5.8 meters in coming to rest.